Hey guys, it's Greg. Just wanted to film a quick introduction to this video because it is a really special one. Today we'll be using large language models using Cohere's API. They are very powerful and extremely easy to use, so I'm really looking forward to it. Thank you to Cohere for sponsoring this video, and let's get into it.
Hey guys, how's it going? So firstly, I am on Cohere's public website, which is great because you actually don't need to know anything about programming or analytics or machine learning or any of that. I'm going to show you how to use their public playground so that you can interact with their LLMs without really doing any of the technical stuff. And you'll firstly see after you make an account, I think I used Google, it's really easy. You'll see this trial API key. Now on your screen that you're watching right now, it's going to be grayed out because I don't want you to know what my API key is. That's kind of the point. You don't share these with people. And so what this does is it allows you to basically send a password when you're using Python or Go or Node.js to the APIs so that they kind of know who you are. And in this case, they know basically that you're not paying them anything. And so there will be some restrictions because of that, but it's still very flexible. Honestly, as long as you're not like constantly pinging their models with a lot of data, you probably won't even notice that it's a trial API key. Of course, if you are looking for production grade quality and even just any application that you want people to use, you probably would want to check out their billing to see if that's something that's worth it for you. It very well might be. So we're going to go over to the playground. So this is their playground. We're going to use the Generate API. It's probably best if you're just using the website, you probably want to use the Generate tab, and Classify is what we'll use in our machine learning project after we play around with the website. So firstly, we are going to generate some text. Don't really worry about all the other stuff for now. Let's just get used to this thing. So one thing they can do is understand conversation. So if you were to do something like, Greg, hi, my name is Greg, and then John. Well, let's just leave that as the prompt. So basically, whatever I have here, it's giving that as its input, or what's called a prompt, and it's going to predict the next set of output. Well, what would we predict? Okay, so as humans with our intelligence, what would we guess? Well, we'd probably guess that it says, hi, my name is John. Let's see what it does, and we'll also play around with these parameters as we do it. So we'll just press generate, and don't worry about this error here, it doesn't really matter. And what it's going to do is produce the next 50 tokens, or basically the next 50 words or periods as well. So I'm John, I'm the finance director at the business. Dave, okay, they're brought in a new character named Dave, and I'm Dave, I'm the managing director. John says, okay, let's talk about cash flow. And Greg, what would you say is the biggest issue with your, man, I kind of wish that I had more tokens because that was really cool. So what you can see here is it understands the real structure of what's going on. It's seen names and colons so much in its training process before that it understands like, okay, this is the person that's talking and they're talking to this other person here. And since it's creative, it allowed it to have some other character, Dave, which is really cool. I don't actually know how accurate this is. Like maybe in its training process, it's actually seen Greg, John, and Dave together before. And so Dave is the managing director and John's the finance director. Maybe these are real people. Maybe this is a story. I couldn't really tell you. All I know is that it thinks that this is the next best set of text for these parameters. You could change this a lot. So if we go all the way up, temperature is a value that ranges from 0 to 2. And the higher it is, the more creative it is. So basically like more poetry. The lower it is, so at 0, it's very accurate. Sort of. So you can't really trust LLMs to be like actually accurate. You can relatively trust something like a Google search engine if you were to search that up and you would look at all the responses. Of course, you'll find false information on the internet anywhere, but this is actually kind of the problem with LLMs, is that you can't say that they're like accurate. You can't really trust them right now. You can use them for many cool things, and we will, and well, we are, but you can't really just blindly trust these things to be accurate, because if we were to make this, say, super accurate, 0 means like more accurate, less creative. If we were to generate this, and it's okay with this stuff here, it'll just fix that up. Hi, Greg. Greg, I'm from the UK. John, oh, okay. Greg, I'm a big fan of your work. John, oh, thank you. Greg, I've been listening to something. So, okay, sure, this is accurate, but I mean, maybe it's accurate to some particular text it's seen before. Still, maybe it's not. And if you were to do something like 5 plus 5, you know, LLMs, actually, I saw some papers on this. People are working on it a lot. But you can't really trust this. Like 5 plus 5, even in the very accurate setting, it's not equal to 10. It's equal to ... and 8 plus 8 is equal to that. And so I see what it's doing. I mean, I don't see the pattern immediately, but I see different numbers. It's like this plus this is equal to that, and so on. But it's not really going to just really corely understand what you're doing. It's just going to predict the next set of text. Okay, and we can really take advantage of this. It's you can't blindly trust them, but you can do some really, really cool things with them, as with the script, basically. So we've seen it can write scripts. Well, why can't it write poetry? Okay, so maybe I wrote a nice poem. Water is blue. A very nice poem, yeah, indeed. Clouds are gray, and so on. Let's see what it does for 100 tokens and temperature of 2. So very creative. That's what you'd want for poetry, probably. It rains from dark clouds. Trees are green. Trees turn yellow in the fall. Birds fly from tree to tree, and so on. Okay, so it can write poetry. It can be very creative in that. And you know, if you put it more lower down, it would kind of say more accurate and specific things about these things, although it kind of already did that. So let's just lower the temperature to see what this happens. But in general, you would want probably a higher temperature value. So here you go. Yeah, as I said, it's kind of saying very accurate, like specific things. The sky is blue, the sun is yellow, the grass is green, the trees are green. But yeah, so it can write poetry, which is really, really cool. It could write, so here's kind of some of their suggestions here. Hashtag generator. So I'll show you how that works. So maybe you wrote a Twitter post and you wanted it to fill in the corresponding hashtags. Now for something like this, you would definitely want to kind of show it that you're actually making a Twitter post. And so we'll make a sample post first. We'll say, this is a cool picture of my dog, Barky. Hashtag dog, hashtag sunglasses. Maybe he's wearing sunglasses. Okay, so that's our sample. And so now what we'll do is just the same thing, but without the hashtags. And we'll change it to, this is a cool picture of my cat. Well, I guess it would be meow, sure. And you could write an optional hashtag to really force it, although I'm willing to bet that we'll put the temperature at about like 1.2, somewhere in the middle. And I'm willing to bet that it's gonna just know that hashtags are coming, since it already saw kind of a tweet-like thing before. Hashtag cat, hashtag sunglasses. Okay, there you go. That's kind of exactly what you would expect, and it could do that. So here I kind of added some other stuff. You don't always need everything from the model. Just output less tokens if you don't want them there, or just, you know, erase the text. It's not a big deal. So there you go. It basically got exactly what we'd expect, which is really cool. If you allowed it to be, you know, a little bit more flexible, you could probably see some more different unexpected results here. So hashtag cat, hashtag shades, that still makes sense, but is a little bit more flexible. And you can see some other stuff is showing up, which you don't really want. Again, less tokens or just erase it, not really a big deal. Okay, so that was a hashtag generation. What about summaries? So here, there's a passage, which is the article. It's a big, long paragraph about Wordle getting tougher. And then we see TLDR, Wordle has not gotten more difficult to solve. TLDR stands for too long, don't read. It just means a summary of it. Okay, and then here we have another passage with a full passage. A too long, don't read. Here is a summary about that article. And then finally a passage with a blank TLDR. So it's giving it two examples, kind of like the tweet. I gave it the dog with the dog hashtags, and then the cat without the cat hashtags. Here it's giving two examples and then a blank, and we'll just let that generate and see what it does. Sorry about the jump there. So I just did a generate, and now it says the National Weather Service has issued a freeze warning, and it is indeed talking about a freeze warning. However, it's not much of a summary because it's still very long. What we'd rather do is decrease this. So maybe limit the number of tokens to say 15. We'll generate that. And there will be a hard freeze this week leading NWS. So it actually knows that a National Weather Service is NWS to issue a something. If you let it be a little bit longer, I would have had a sentence. Probably should make it at least 30. So we're going to get a guaranteed sentence. It won't be the same thing every time. This will change. You may need to protect some plants or bring your pets indoors to avoid the cold. Now, this is not the most awesome summary, and if you don't like your result, you can always just click it again. There you go. Freeze warnings have gone into effect for much of the Bay Area. That is pretty much the main message that was trying to be conveyed here. So that's really cool. As long as you have some clever way of kind of telling it what you're trying to do, here's a passage, here's a summary, here's a passage, here's a summary, here's a passage, tell me the summary. Or with the script, here's Greg saying something, here's someone else saying something, or maybe make a person and say something, make some poetry. As long as you have some kind of clever way of making it do what you want, it can do some really cool things. So I'm going to close up the playground now. Feel free to check out their other examples, which are kind of just other clever ways of doing the same thing. And now I'm going to go to Google Colab, where we'll make a full machine learning project on spam detection. Okay, so I just booted up a new Colab notebook, and it's really easy to get Cohere installed. You just do pip install Cohere like that, let that run, and it's going to download the Cohere API and put it in your Python environment. So there you go. It's actually really fast too. That's already done. And now what we're going to do is import it. So we will do a quick import Cohere, and then we write co, short for Cohere, is equal to cohere.client. And this is where you have to pass in your API key as a string. Now I'm going to do that, but I'm not going to show you the actual key. So you have to make your own account and then create your own token. Actually, I think it creates the token by default. It's just on the dashboard. I will be graying it out because I don't want you to see my key. Okay, so I'm just going to put it in there. It's just in strings. If you run that, you shouldn't see any errors as long as you have a valid API key. Okay, so now we are just going to do something similar to what we were in the playground, but through the API to get used to it. So we'll do response. So like a traditional kind of HTML response. Response is equal to co.generate. We're writing generate because, we were using that generate playground before. So we need to specify a few things. We'll specify the model size. The bigger the model, the slower it will be, but the better your responses will be. And inversely, if you have a small model, it'll be fast, but it might be a little bit worse. Now, I've found that the large models are actually pretty fast, and so there's no need to not just utilize the extra large. Check their documentation if you have trouble with a particular model, because I know that they are constantly making updates as to what models they're offering. Right now, X large like that seems to work well. And then you specify that prompt, which is it's the text that we were writing in the playground. I'm just going to say something that we wrote before, which is Greg says, "Hi, my name is Greg." And then we'll actually we'll make that the prompt and see what happens. Okay, we'll set our tokens. So max tokens is how much it's going to produce. We'll set that to say 100 tokens it'll produce. And our temperature value from before, from 0 to 2, temperature we'll set just equal to 1 is a good default. Okay, so we'll do that. And the best way to print your response is just like this. Print response.generations sub0.text. I know that it's kind of random how I got this. Don't worry about it. That's just the way to get the prediction. Okay, so it's going to ping the website and it's going to utilize their API. Given the prompt, it now says, "I am a therapist, a social worker, a Buddhist, and an ordained monk. I am a professional meditation teacher, something, something." Okay, cool. So this Greg seems to be a monk. Very, very interesting. All right, so we already played around with the API for generation, so I'm not going to use that anymore. That was just kind of a quick introduction to show you what we were doing on the website, and now here's how to do it in Python. But for this example, for this whole notebook, we are going to do, as it says at the top, spam detection, and it's going to use their classify API. So here we'll do from cohere.classify import example. Now, examples are basically like input-output pairs. So for supervised learning, you feed things, many input-output pairs. Traditional neural networks take like thousands or millions of input-output pairs, but this model is going to do something called few-shot classification, where instead of training it like with a ton of data, we're just going to feed it a little bit of data, something that's part of our niche, part of our data set, a few examples, literally just 5, 10, 20, something like that. And since this model's already really good at understanding text in general, we can actually make it understand our text data pretty easily. So I'm just going to show you some examples. This is not going to be for our spam detection. This is just a simple sentiment analysis. So we'll do examples is equal to the list of example of, we'll just make something very obviously positive. Hey, this is good. Okay, so this is a positive sentiment, and so we'll label that as positive. So this is one of our examples that is saying like, okay, this is an example of a positive sentence. Now, how about a negative sentence? Well, I'm just going to copy it in here. It's a little annoying to type. Example, nah, this is bad. So it's, it sounds kind of bad. And we'll label that as negative. Two more, but very, very similar to the others. Just to give it, I think it requires 2 of each category. And positive or negative, we just made those as categories. You could have called them something else. Hey, this is very good, which is positive. Nah, this is very bad, which is negative. We'll close up that list. And now we need to make something called inputs. So inputs is actually what we want the prediction for. It's what we want to do inference on. And so our inputs, again, we're just doing a simple sentiment analysis as an introduction example. We will do, okay, so that's kind of a negative thing. We have not good. Well, if it's not good, it's probably bad. And this is great. Okay, so we're going to teach this model that, hey, this is what our data looks like. It's kind of like a loose person talking, and it's either positive or negative sentiment. And then we want to ask, hey, is this positive or negative? Is this positive or negative? Is this positive or negative? So our examples are teaching the model a little bit, and the inputs are what we want inference on. So to use the classify API, it's really, really similar to the other one, but we'll do response is equal to co.classify, and we're going to send it the model size. We'll just use a small, fast model for this. Inputs is equal to inputs, and examples is equal to examples. Okay, so we teach it with the examples, we get inference on the inputs, and we can see our responses. I'll actually print it in a little bit of a different way. Print response.classifications. It shows a list of these classification prediction things. And you could use the help function to kind of look at each of these and figure it out. We'll look at that a little bit more later when we need to diagnose these things. But here you can see the first one is negative. So the first one, is negative. It knew that. The second one is also negative. Not good. There you go. It's negative. And the last one is positive, and they all have confidence is relatively high. Okay, so isn't that really cool? You just give it a couple examples. To be honest, it probably wouldn't even need any examples. It's just out of technicality that it requires a few examples, and it already knows sentiment analysis. That's really cool. So now that we know how this API works, we are going to do it for a spam detection model that is on a Kaggle dataset. Now for Kaggle dataset, it's actually going to be another API key. So you need to go into your Kaggle account, or make one if you don't have one, go into your Kaggle account and click generate API token. And it's going to create this JSON file and download it to your computer. And what you're going to have to do is go over here and upload that JSON file. It should be called kaggle.json. And again, I can't show you my API key, so I'm just going to make it magically appear here. Okay, it's just some kaggle.json file. If you were to click on it, it would show you a brief thing with an API key, which allows you to download Kaggle datasets, which is what we are now going to do. So we'll do some Linux commands, mkdir, and then you really don't have to know this. In fact, I'm actually just going to copy paste it because it's not very interesting. Just a couple of Linux commands that say mkdir, and then make this folder called Kaggle in the home directory. Copy this kaggle.json file that we uploaded into that Kaggle folder. It just needs to be there. And then we change the modifications of that file, and then we do this Kaggle datasets download, and this is the dataset that we'll be using. Thank you to this person for creating or sharing the dataset, whatever it was. Okay, so we're going to run that. Hopefully you get no issues, and we are going to have one big file here, spam classification for basic NLP.zip. Okay, so we don't really like zip files. We are going to unzip that. I'm going to copy and paste this again, just because it's a lot easier. Unzip spam classification for basic NLP.zip. We unzip it, and we get a CSV. Okay, so you should see some CSV over here. So our CSV is called spam email raw text for NLP.csv. So let's take a look at this. Classic import pandas as PD, and we'll make a data frame df is equal to pd.read CSV with spam email, make sure you get the capitals and everything right, raw text for NLP.csv, and then we'll just look at the first few rows, df.head3. We can see it opens it, and we have three main columns here. We have a category, which we'll look at shortly, a message, which is basically an email. It's just a big string representing an email, and it has some file name. We actually really don't care about the file name column, so I'm going to get rid of that. df is equal to df.drop, the file name column, file name, and that has to be on axis equals 1, and df.head3 again should be the same thing, but without that column we don't need. Okay, so let's look at a couple things. Let's look at the first row here. So print df.iloc sub 0. So that basically says grab the row with this first index here. And let's first look at the message value. Okay, it's all in capitals, message, like that. Print. Okay, so it's just printing this thing out here. And it's this big thing. Interest rates are at their lowest point in 40 years. No, they're not. At the time of writing, they're at their highest point in 40 years, I think. We help you find the best rate for your situation by matching your needs with hundreds of lenders. This looks like spam. It's sending it off to dear homeowner. It's like they don't even know who you are, and they're talking about interest rates, about money and finance, and it does not seem right. And there's then simple forum, visit this sketchy link. Please don't click this. I actually have no idea what this is. Probably nothing, but yeah. So we don't want that. To unsubscribe, don't click that either. You can also see it's not secure. It doesn't have the S on there. Okay, so as it clearly looks like spam, well, we should be able to look at the category. So print df.iloc sub 0 subcategory, and then we'll see that it's 1. So basically 1 is representing that it's spam, and 0 is that it's not spam. So if we were to look at some other messages, they would have category 0, which means they're just actual emails that you would want to have in your inbox. Okay, so let's do a little bit of preparation here. So we're going to make a model using Cohere's LLMs. It makes sense because our input is text and it understands text really well. So we're going to teach this model how it can figure out automatically whether an email is spam, or I guess spam or ham is what people say traditionally. It's kind of funny, spam or not spam. So I'm going to first shuffle around the data set. I'm going to do a lot of traditional machine learning based stuff. df is equal to df.sample. Sorry, that's all in capitals. df is equal to df.sample with frac equals 1. And random state equals just some number to make sure that you and I get the same results if you are to do it. Random state is equal to 2. So this basically just says shuffle around the rows, and it happens to mess up the index column. So you have to do df is equal to df.reset index with drop equal to true, just because it makes some annoying column. df.head3. Now it is just this shuffled data set. So you can see here, this is not the same row. This is not the same first row as it was before. These are all happen to be not spam. it's very important to understand the distribution of your data set. So is it balanced or imbalanced? Is there a lot more spam than not spam, or the inverse? And so with this, you can look at the distribution of the category column with df sub category dot value counts. Okay, so this says that there are 3,900 rows with not spam and 1,896 rows of spam. It's a little bit over double for the not spams compared to the spams, but honestly, this is probably fine. It's not super imbalanced. It's not like 99% to 1% or worse. It's pretty good. So there's a couple things that we have to do to format the data before we can send it off into the Cohere API. Which is first make this column that basically turns that label into, or that category label 0 or 1 into just not spam or spam. A simple function that'll take this and convert it to not spam, and can take this and convert it to spam as strings. So we're going to define a function, define category to label, and it's going to be taking a category num, which is just taking on the value of either 0 or 1. And we'll just say if the category num equals 0, that means it's not spam. So we'll return the string of not spam. We'll just do it like that. Else we can return spam because it must be a 1, which is spam. Okay, and we will just apply this to our category column, but we'll make it a new column. So we'll say define the category label that is equal to the df, get out of here capitals, df sub category dot apply with category to label. So we applied this function to this column here. So what we should see if we do df.head3 again, we have some new column, which is category label. Since these are zeros, it's not spam. And if you were to look at some rows that had a category of 1, it would just say spam. Now you wouldn't know this unless you really dug into the text data set like I did, but I found that there is some problems with the text sometimes. Like there's some weird letters like lambda and alpha and kind of stuff like that. That's just not really letters, not really stuff that you'd really want in there. And it'll really not just confuse a model, it'll literally break a model. And so I'm going to make a function that uses regular expressions to only keep stuff that's actually important to us. So we'll import RE, that stands for regular expression, and define fix string of S. So it takes a string, we're going to apply this function to this column here. And we'll just make this thing called whitelist. It's basically the things that are going to be accepted. So whitelist is going to be the set of, I'm just going to copy this in here because it's a lot of stuff. And I actually just realized that now that I see this, that I should allow more than this. Basically, this is all of the letters that are lowercase, space, all the uppercase letters, and then the numbers. But we also want to allow dot, comma, and probably quotes, although it's not a big deal. And actually, let's just do those two. And so any character that's in a message that's not one of these characters here, it's not going to be allowed into the returned string, basically. And we could do that with a little bit of extra work. S is equal to the string dot join, and the filter of whitelist dot underscore underscore contains underscore underscore S. Don't really worry about that too much. It just basically does what I said it would do. And we will return this new string. So we take a string, we make sure that all of its characters are one of these characters here, and just remove those characters if it's not something that you would want. Okay, so we'll do apply that function. Df sub message is equal to df sub message. So just overwrite that column, make it dot apply the fix string function. And as we've seen every time, df.head3, show the first 3 rows. There you go. I'm not sure if you can see a difference. You can see it got rid of some new lines. Actually, you probably want new lines as well. So I'm going to try and keep that in there. Does that work? Yes, but it already redid it. Actually, I'm going to run all of this again. Sorry about the headache there. I realized I do want to keep new lines as well. So let's just run that again, all of this again, and hopefully, yeah, you can see it keeps the new lines there. If we run into any issues with the new stuff I added here, I'll just remove it and we'll do it again. Okay, so now there's this function that you might not like too much. It turns out that there's a couple rules about the Cohere APIs, and that's understandable. Every API has some rules. I did have a little bit of trouble figuring out exactly what it wasn't liking, because there were some moments where it was just kind of saying like server error, but it wasn't actually like just a server problem, or it said broken pipe. And I had to do some figuring out as to what was really wrong with it. And I came up with this function that seemed to really process the text in a way that it was okay with. It has to do with it couldn't take too many tokens, and it also couldn't have any tokens that are too many letters. So for example, it couldn't have a message that was like 1,000,000 words long. And also, if there was one word in there that was like, 1,000 characters, like something like a link like this, it's just super, super long, and that converts into one token, then that was also an issue as well. So I eventually created this function, which I'm just going to call truncate. It does a little bit more than that, but I'm just going to call it truncate, which takes a message. And similar to above, we're just going to kind of return a new string. Word list is equal to message.split on the space. Okay, so we're going to get it basically what it does for the tokens, but not precisely. And then word list is equal to word list sub up until 400. That basically says get the first 400 things separated by spaces. That's pretty much the tokens. It's not exactly what the tokens are, but a token is very similar to a word. And so basically getting the first 400 tokens. Then we'll do word list is equal to the list of word sub up until 50. So this is basically saying, okay, make sure that every word is at most 50 characters. If there's a word that has way like more than 50 characters, just don't keep the other stuff. Just keep the first 50. So we'll do that for word in word list. And then we pretty much just need to convert it back into a string. Message is equal to the string dot join. But then actually this word list got rid of the spaces, and so we kind of need to bring them back. Dot join with the word with the list of word plus a space for the word in the word list. Okay, so for each of those words that were in our list of words, we are just going to, put a space after them. And this will put a space at the end, but it doesn't really matter. As a final check, I just want to make sure message is equal to message up until 450. So again, we're just really making sure that this, actually I should just make that 400. Just take the first 400 words, and we've made sure that all of them are 50 characters. This function is probably not perfect. You can probably write it in a better way, but it gets the job done. We will return the message, and we'll do the same thing as before, but just make a new column, define truncated message is equal to df sub the message column dot apply the truncate function, and df dot head 3. Sorry, I have an extra bracket there. That's not right. And here we go. So we now see a new column, truncated message, which basically is just our final string that it's actually going to allow into the text model. So now we are going to generate some examples, just like we did above with the sentiment analysis model. We sent it 4 examples, 2 of each. Here we'll send it a little bit more. Here we're going to send it a little bit more examples. We'll just send it, say, the first 100 shuffled data, and we'll see how that works. Okay, so we'll set this parameter, and we'll change it later to see how it affects the model. Train size is equal to 100. So that's saying that take the first 100 rows of the data and then make examples out of that to train the model. And then we'll do examples is equal to the list. This just automatically generates the examples. Example of message and label for message label in the zip. I'm actually going to just copy this because it's a little bit a little bit tough to write, but it's not too tough to understand. For message and label in the zip of this. Now it looks hard to understand, especially because we can't see it all. Examples is the example of message and label for message and label in the zip of the truncated message up until the train size and the category label up until the train size. This message is going to loop over this, and this is just the truncated messages, only the first 100 of them, the first train size of them. And then this label is going to loop through the category label, and the category label is the not spam or spam. Okay, so it basically just automatically generates our examples for us. And sorry, I missed a bracket there. Okay, so those are our examples. We should see the length of the examples is 100 of them. Okay, now we have to generate our inputs. So what do we want to perform inference on? Well, we'll perform inference on anything that we did not send as an example. So that's basically train size or 100 onward. So we'll set inputs equal to the df sub truncated message column. Those are our inputs, sub the train size onward. Okay, so all the other ones, and then it needs to be a list. So we'll do dot to list. And you can see just if you look at the first couple inputs up until say 5, it's just the strings. It looks really irritating, so let's not look at that. And let's just look at the length of the inputs. So len of inputs, we can see that there is 5,696. So now we just need to do the same classify thing as above, however, with a slight twist. Since we are sending it so much data, you actually need to partition this into multiple API calls. So you just need to call the classify thing a few times. What I found in the documentation is that they actually say that a single ping can only have 32 messages in it. However, I found in practice that currently that's not the case. So if in the future you have trouble when you have, like if you're doing the same thing, it might be that you need to send it in batches of 32 messages, and with a slight refactor of the code, you could do that. However, I found that I could just do 3 responses, so split it into 3 roughly equal batches. We're going to use the model type of medium here. However, I did see that I think they might be retiring their medium. I saw an email that says that they're changing up their sizes. So just check out the other sizes if this doesn't work at the time and use a different one. I think they're extra large that they're keeping for sure. And then we're just going to do this into 3 responses. I'll show you the first one. First response is equal to co.classify, where we're specifying the model is the model type. And then the inputs, this first one is going to be inputs from up until 2000. So just the first 2000 inputs. And our examples are going to be all of our examples. The second 2 responses, I'm going to copy in. They're very, very similar, but just with, the other parts of the other rows basically. So second response is the same thing, but just 2000 up to 4000. And then the third response is the same thing, but just 4000 up until the rest. And I will just quickly print the first response, and this might take a little bit of time. Okay, so that finished in about a minute, which is actually really good for all of that data. And in general, it has a very high confidence. Pretty much everything here, it seems very, very confident, which makes us feel pretty hopeful about the scores of our model. Now let's do a couple post-processing things. We'll get our list of responses. It's just joining them together. Responses is equal to list of first response plus the list of the second response plus the list of the third response. So that's just all of them together. And the length of the responses should be 1 for everything we sent in, 5,696. We can extract the predictions by just any of these things dot prediction. So responses sub 0 dot prediction is not spam. So that's basically just that keyword there. It's whatever we predicted. Now let's look at the performance of our model using Scikit-Learn. So I'm going to use the category column that has the 0s or 1s. And so we're going to convert these back into 0s or 1s as well. But first we just have truths is equal to df sub category dot to 2 numpy from train size onward. Now that looks a little bit confusing. Basically, it's just the vector of the actual labels that correspond to our predictions. So df subcategory dot 2 numpy train size is just a numpy vector of either zeros or ones, where it's the true label of either not spam or spam. And so truths sub 0 is just a 0. That one happens to be not spam, which is good because we predicted that the first one was not spam, and so we know at least that one is correct. Now let's get our predictions. So predictions is equal to the list of r.prediction for r in the responses. Just extract all of the predictions, and so if you look at the first 5, we'll see that, they're actually all not spam. Now we'll just convert the not spam into 0 and spam into 1, and we'll make it a numpy array that will match up well with our truths vector. So we'll do import numpy as np and say predictions is equal to np.array, where it's the list of 0 if p is equal to not spam, else 1, and that's for p in the predictions. Okay, and then we look at the first few. Hopefully they look the same as the labels here. So truths, if you look up until truths up until 5, we see, oh, actually it's got one wrong here because the middle one is spam, but the middle here was predicted as not spam. Okay, so we know that it got that one wrong. Let's look at our classification metrics. From sklearn.metrics, we'll import the classification report, and we'll print the classification report with the truths and the predictions. Let that run, and we'll see a very, very good score. Okay, so this is actually phenomenal. An average F1 of 0.94 is just awesome. It's clearly good at both positive and negative examples here. As a comparison to one of my models that has trained, with a lot of data, like it's trained with thousands of examples and then tested on the very small portion, whereas this model was trained on a very tiny portion and then tested on almost everything. This is how my other model did. It got an average F1 of 0.8 with so much more data trained. So Cohere's API, like this is miles, like so much better than traditional machine learning. These large language models are tremendously powerful. You can give it a very small amount of data, and it's going to be better at than traditional models with more data. Okay, and if you wanted to, you could play around with a few things. The train size in particular, the train size here, you could make that smaller or bigger, as long as you had, I think, 2 of each, both not spam and spam, then it would probably be okay with that. As well as if you have to change the model type, if that didn't work, you might have to change that as well. Feel free to change it anyway, even if it did work. And there you go. That's our project. Like it's so good. Like here's our spam detection model. It clearly works really well on this data set. It's, to be fair, a little bit of an easy data set, but you could absolutely use this for any of your projects if you wanted to get production grade quality and really get some awesome applications out there for people to be using, all the time. Then definitely check out their billing and seeing if that's worth it for you. It definitely could be. And, thanks again for Cohere for sponsoring this video. I really appreciate it. And I had a great time using it. It's really cool. This is actually my first time really playing around with these, just fully text-based LLMs. Really, really cool. So thanks so much. And yeah, I'll see you guys later. Bye-bye.